about integrating trigonometric integrals. Okay, so here we go. We look at this one and we're curious. We don't have a u du, so what do we want to do? Let's go and let's do parts. Bam. So I'm going to let u be x, and dv is the secant tangent x, dx. Then what's next? We get our du, that's dx, and our v is the secant x, because when we integrate the secant tangent, we get secant, its derivative. Sure. So now we're using by parts, my u dv, that's uv minus the integral v du, and I put all my pieces in place. So I only got to do one more thing. I got to integrate that secant of x. So then that's x secant x times the natural log of the absolute value of the secant of x plus tangent of x plus c. We're done. It's all over but the box and flower. Now some of you guys are saying, wait a secant. How did you get the integral of secant to be that? That's this. So if I'm looking at the integral of secant, I can multiply top and bottom by secant plus tangent, essentially not changing anything, because we're multiplying by 1. Then what? We can distribute in that secant, and when we do, we get secant squared plus secant x tangent x all over secant x plus tangent x dx. What's next? Okay, sure. So then you look down there in that denominator, and you're like, why don't I let that be u? Okay. Then du, oh look, how cute. That's the numerator. Sure. So what do I have? I now have an integral that's du over u. Well, naturally, that's the natural log. And all we got to do next is back sub. And that's how we got the integral for secant.